Good morning, students. I am Jacobi, working as Associate Professor in the Department of Mathematics. In this video, I am going to explain Gauss-Jacobi's iteration method to find the solution of linear simultaneous equations. This video is useful for 5th semester BSc students. Now, what is Jacobi's iteration method? We have understood direct methods to find the solution of linear simultaneous equations. Direct methods yield the solution after a certain amount of fixed computation, whereas iterative method is that in which we start from an approximation to the true solution and obtain a better and better approximation from a computation cycle repeated as often as may be necessary for achieving the desired accuracy. In this method, the amount of computation depends on the degree of accuracy required. Okay. Now let us consider the system of equations. A1 into x plus b1 into y plus c1 into z is equal to d1. A2 into x plus b2 into y plus c2 into z is equal to d2. A3 into x plus b3 into y plus c3 into z is equal to d3. If a1, b2, c3 are large as compared to other coefficients, then we solve for x, y, z using Jacobi's iteration method. Suppose a1, b2, c3 are not large as compared to other coefficients, then we interchange the equations and see that a1, b2, c3 are large as compared to other coefficients, and then use Jacobi's iteration method to solve for x, y, z. Okay. Now let us rewrite these equations. Now from the first equation we have a1 into x is equal to d1 minus b1 into y minus c1 into z. Therefore, x is equal to 1 divided by a1 multiplied by d1 minus b1 into y minus c1 into z. From the second equation we have b2 into y is equal to d2 minus a2 into x minus c2 into z, or y is equal to 1 divided by b2 multiplied by d2 minus a2x minus c2 into z. Now consider the third equation. Let us calculate z. c3 into z is equal to d3 minus a3 into x minus b3 into y. Therefore, z is equal to 1 divided by c3 into d3 minus a3 into x minus b3 into y. So given a system of equations, we rewrite the equations in this form. That is the first step. Okay. Now let us begin with initial approximation for the solution. Say x0, y0, z0 be the initial approximation for x, y, z respectively. Now let us substitute x is equal to x0, y is equal to y0, z is equal to z0 in these equations, on the right hand side of these equations, and obtain the first approximation or the first iteration for x is equal to x1, y is equal to y1 and z is equal to z1. Okay. So let us begin with x equal to x0, y is equal to y0 and z is equal to z0. Therefore, first iteration gives x1 is equal to 1 divided by a1 into d1 minus b1 into y0 minus c1 into z0. y1 is equal to 1 divided by b2 into d2 minus a2 into x0 minus c2 into z0. z is equal to 1 divided by z is equal to z1 is equal to 1 divided by C3 into D3 minus E3 into X0 minus B3 into Y0. So, X, Y, Z ಇದ್ದಲ್ಲಿ X0, Y0, Z0 ಹಾಕಿದ್ರೆ ಆಯಿತು. ಆ ವ್ಯಾಲ್ಯೂಸ್ ಹಾಕಿದ್ರೆ ಆಯಿತು. ಸೊ ಫಸ್ಟ್ ಇಟ್ರೇಷನ್ ಅಲ್ಲಿ ನಮಗೆ X1, Y1, Z1 ಅಂತ ಸಿಗ್ತದೆ. We have substituted for X is equal to X0, Y is equal to Y0 and Z is equal to Z0. Okay. So X1, Y1 ಮತ್ತು Z1 ಸಿಕ್ಕಿತು. Now in place of X, Y, Z, we substitute X is equal to X1, Y is equal to Y1, Z is equal to Z1. That is, here we substitute Y1, here we substitute Z1, here we substitute X1, here Z1, here X1 and here Y1 and obtain the next iterations, that is X2, Y2, Z2. Therefore, X2 is equal to 1 divided by A1 into D1 minus B1 into Y1 minus C1 into Z1. Y2 is equal to 1 divided by B2 into D2 minus A2 into X1 minus C2 into Z1. Z2 is equal to 1 divided by C3 into D3 minus A3 into X1 minus B3 into Y1. I hope it is clear. Okay. Now continue this process till the difference between two consecutive approximations is negligible. So if the initial approximation is not given, then we may choose X0 is equal to Y0 is equal to Z0 is equal to 0. So Jacobi's iteration method is, given a system of equations, we rewrite the equations in this form. We begin with the initial approximations X0, Y0, Z0. We find the first iteration or the first approximation X1, Y1, Z1 by substituting X is equal to X0, Y is equal to Y0 and Z is equal to Z0. We find the second approximation X2, Y2, Z2 by substituting X is equal to X1, Y is equal to Y1 and Z is equal to Z1. Continue the process till the difference between the two approximations is negligible. So if initial approximation is not given, we choose X0 equal to Y0 is equal to Z0 is equal to 0. I hope you have understood Jacobi's iteration method. Now let us solve one problem using Jacobi's iteration method. Problem is, solve by Jacobi's iteration method 20x plus y minus 2z is equal to 17, 3x plus 20y minus z is equal to minus 18, 2x minus 3y plus 20z is equal to 25. Okay, now observe the equations. Say this element is 20 which is greater than 1 and minus 2. Again, this element 20 is greater than 3 and minus 1. Therefore, these elements are large as compared to other coefficients. Hence, we use Jacobi's iteration method and we rewrite the equations in the form 20x is equal to 17 minus y plus 2z, or x is equal to 1 divided by 20 into 17 minus y plus 2z. 20y is equal to minus 18 minus 3x plus z, or y is equal to 1 divided by 20 multiplied by minus 18 minus 3x plus z. 20z is equal to 25 minus 2x plus 3y, or z is equal to 1 divided by 20 multiplied by 25 minus 2x plus 3y. Okay. Now let us mark this system of equation by 1. So we have x, y, z. Now observe, initial approximation is not given. So assume x0 is equal to y0 is equal to z0 is equal to 0. 0 ವೇ ತಗೊಳ್ಬೇಕು ಅಂತ ಏನಿಲ್ಲ, ಬಟ್ 0 ತಗೊಂಡ್ರೆ ಕ್ಯಾಲ್ಕುಲೇಷನ್ ಸುಲಭ ಆಗುತ್ತೆ. ದಟ್ಸ್ ವೈ ವಿ ಕನ್ಸಿಡರ್ x0 equal to y0 is equal to z0 equal to 0. Okay. Now what is the first iteration? We substitute y0. We we substitute y is equal to y naught, z is equal to z naught, and x is equal to x naught in the right side of equation 1. Okay. So first iteration is x1 is equal to 17 divided by 20, because initial approximation is equal to 0. Therefore, x1 is equal to 17 divided by 20. This is 0. 2 into 0 is 0. So 17 divided by 20. y1 is equal to minus 18 divided by 20. z1 is equal to 25 divided by 20. So first iteration is x1 is equal to 0.85. y1 is equal to minus 0.9. z1 is equal to 1.25. Understood? Okay. Now let us consider the second iteration. Second iteration igaguvaga, we substitute these values for x, y, z on the right hand side of equation 1. Okay. So we substitute x is equal to 0.85, y is equal to minus 0.9, and z is equal to 1.25 on the right side of equation 1, and we get x2 is equal to 1 by 20 into 17 minus y1 plus 2z1. Substitute for substitute for y1 and z1. Simplify, we get x2 is equal to 1.02. y2 is equal to 1 by 20 into minus 18 minus 3x1 plus z1, which is equal to minus 0.965. z2 is equal to 1 by 20 into 25 minus 2x1 plus 3y1, which is equal to 1.03. Observe, x1 is 0.25, x2 is 1.02. They are not same, isn't it? y1 is minus 0.9, y2 is minus 0.965. z1 is 1.25 and z2 is 1.03. The values are not same. We continue the process. So third iteration is substitute x is equal to x2, y is equal to y2, and z is equal to z2 on the right side of equation 1 to get x3, which is equal to 1 by 20 into 17 minus y2 plus 2z2. Substitute the values, that is equal to 1.00125. Similarly, find y3. We get y3 is equal to minus 1.0015. z3 is equal to 1 divided by 20 into 25 minus 2x2 plus 3y2, which is equal to 1.00325. Now compare the values. x3 is equal to 1.00125. What is x2? It is 1.02. They are not same, isn't it? y2 is minus 0.965. y3 is minus 1.0015. The values are not same. Therefore, we continue the process. So, find the fourth iteration, fourth approximation to x, y, z. Substituting x is equal to x3, y is equal to y3, and z is equal to z3. On the right side of the equation 1, we get x4 equal to 1.0004, y4 is equal to minus 1.00025, z4 is equal to 0.9965. Compare the values obtained in the third iteration and fourth iteration. They are not same. Okay, so continue the process again. Find x5, y5 and z5 similarly by substituting x is equal to x4, y is equal to y4 and z is equal to z4 on the right side of equation 1. Okay. Now again compare the value. The values are not same. Proceed. Continue the process. Obtain x6, y6 and z6. Okay. Now observe these values. x6 is equal to 1. x5 is equal to 0.999, which is almost same, isn't it? y6 is equal to minus 0.999 and y5 is minus 1. z6 is equal to 0.9999 and z5 is equal to 0.9999. Now if you compare these values, the values in the fifth iteration and the sixth iteration are same, practically same. Therefore, we stop the iteration process and write the solution. Hence, the values are obtained to the desired degree of accuracy. Therefore, x is equal to 1, y is equal to -1 and z is equal to 1. Hence, by Gauss-Jacobi's iteration method, we get the solution, and solution is x is equal to 1 and y is equal to -1 and z is equal to 1. Okay. So this method is known as Gauss-Jacobi's iteration method. We carry out iterations or approximations till the values are obtained to the desired degree of accuracy. I hope you have understood the method. Now reference book is Numerical Methods in Engineering and Science with Programs in C and C++ by Dr. B.S. Grewal. I shall stop here. Thank you.